So now that we know everything there is to know about rational functions, let's graph them. So when we graph, we're going to look at the x and y intercepts, which we know how to find. Again, think about restricting your domain as well. Determine the vertical, horizontal, slant asymptotes, whatever your particular function happens to have. Graph those as dashed lines. Determine if there's any symmetry. To be honest with you, I sort of skip that step a lot. But then I do plot at least one point on each interval to determine the shape of the graph. So let's take a look. Here's my function, x squared minus x minus 6 over x squared minus 5x minus 6. First thing I would do right off the bat is if I can factor any of these, I will. So this looks like it factors into x minus 3, x minus 2. And this one looks like it factors into x minus 6, x plus 1. So nothing is going to go away. I'm not going to have holes in my graph. I'm just going to have some asymptotes. My intercepts is, of course, if I plug in 0. If I plug in 0 on the top, that would give me negative 3 times negative 2. On my denominator, I would get 0 minus 6, which is negative 6, times positive 1. Oops, I screwed up somewhere. This should be a plus 2. So that's a plus 2. And then 0 plus 1 is 1. Negative 3 times 2 is negative 6. Negative 6 times 1 is negative 6. My intercept is 1. So that's my y-intercept. Looks like that's my scale. My x-intercepts would be if the numerator is equal to 0. So I'm going to set x minus 3 equal to 0. Let's do x-intercept here. So if x minus 3 equals 0, then I would get x equals 3, which, what are we even going by? It looks like by 2. And then if I set x plus 2 equal to 0, then that would give me negative 2. So at negative 2. So those are my x-intercepts, and that's my y-intercept. Now I'm going to look at my asymptotes. So intercepts, I'm looking at the numerator. Asymptotes, I'm looking, of course, at the denominator. I've already determined that nothing's going to cancel, so there's not going to be any holes in the graph. It's just going to be asymptotes. And there should be an asymptote, a vertical asymptote at x equals 6 and at x equals negative 1. So at x equals 6, which is here, and at x equals negative 1, which is here. So that's my vertical. Horizontal asymptotes, I'm looking right here. Remember, they have the same degree, and if they have the same degree, I'm looking at the coefficients, so 1 over 1, so y equals 1 would be an asymptote. Symmetry, I'm going to say no, because if I look, I see that my asymptotes have already sort of shown me that there's not going to be any symmetry. So now I'm just going to try to find some points. So it looks like this, I know from here that this has to go towards that 1, that y equals 1 value. I know that because I know that as I approach negative infinity, I can't cross that asymptote. And I know that I can never cross this asymptote. So I know this one's going to look sort of like this. It's going to be a little more curvy, but you get the idea. Here, I've got something happening in the middle, and I'm not sure exactly what it is. So here's where I might want to find a point. I know that this is probably either going to go towards positive infinity or negative infinity. But let's take a look at, say, plugging in x of 5. Let's see what happens when I plug in 5. If I plug in 5, I would get 5 minus 3, which is 2. I would get 5 plus 2, which is 7. On the bottom, 5 minus 6 would be negative 1, and 5 plus 1 would be 6. So that would give me 14 over negative 6. So that, of course, reduces to negative 7 over 3. So I know at 5, which is right here, I'm at negative 7 over 3, which is sort of right here. So my guess then is that I've got something like this happening in the middle of my graph. So I've got this going to positive infinity, this going to negative infinity. That's of course where those vertical asymptotes would come in handy. The last part is my horizontal asymptote, and I have no idea what's happening because it's either going to go from up here and then towards 1 on the positive infinity, or it's going to come from down here. And so in order to figure that out, I have to just plug in some number. So let's plug in 8 and see what happens. So f of 8 would give me 8 minus 3, or 5 on top, 8 plus 2, which is 10, 8 minus 6, which is 2, and 8 plus 1, which is 9. That gives me 50 over 18. This is clearly a positive value. 50 over 18, I don't even need to know exactly what it's going to look like. I just know that at 8, which is 2, 4, 6, 8, I know that it's up here. So that means it's going to look something like this. So that's my graph. If you would like, go ahead and plug that then into some sort of graphing utility to check to see if we are correct. Okay, let's try another one together. Now this time I have 2x squared as a numerator and x squared minus 4 as a denominator. I'll start with my intercepts. To find my intercepts, first I plug in 0 for x, which of course gives me a 0 on the top and a negative 4 on the bottom. So 0 over negative 4 is just 0, which means I've got it crossing at 0, 0. I don't need to find the other intercepts because I already know that not only does it cross y at 0, it obviously crosses x at 0 too. And if I would set 2x squared equal to 0, I again would find 0. So that's really my only point where it's going to cross, is at 0. For asymptotes, remember I'm looking at the denominator, which factors into x plus 2, x minus 2. And so that would be my vertical asymptotes would be at x equals 2 and x equals negative 2. And we've got a scale of 1 here, which is helpful. So these are my vertical asymptotes. Again, I found those by looking at the denominator and saying what could x not be equal to. To find the horizontal asymptote, I'm going to look at 2x squared and x squared. And if I took 2x squared over x squared, that would just reduce to y equals 2. And so that's going to be my horizontal asymptote. So that's going to tell me what's happening as I approach negative infinity or positive infinity. There could very well be some symmetry here, and as I look at it, I've got even, even, even. So this actually is going to be even, which means whenever I find a point, it's going to be exactly the same on the other side, so it's symmetric to the y-axis, which that's going to help a lot, because once I get, say, what's happening over here or over here, I'm just going to flip-flop it. So it's symmetric to y-axis. And now I just need to find some points. So choose a value, plug it in, and see what happens. So I need to find something that's happening over here, let's say negative 3. If I plug in negative 3, that gives me 2 times 9 on the top, and then 9 minus 4 on the bottom. So at negative 3, which is right here, I'm at 18/5, which is 3 point something. So that tells me pretty definitively that this is what that graph is going to look like. Somewhere in there. This is not exact, and it doesn't have to be. So I know that it's, as I get closer to 2 from the left-hand side, it's going to infinity, and here it's going to towards y equals 2. I need to find what's happening inside of here. So I know that I can't cross this, so it's probably going to end up looking like one of these, because I know obviously that it goes through at this point. Before I do that, I am going to go ahead and just flip-flop this part of my graph, because obviously that's what's happening on that part of my graph. So let me find, say, f of negative 1. Actually, let me find f of 1, because positives are easier. So f of 1, on the top, that gives me 2. On the bottom, that's 1 minus 4, which is negative 3. So at 1, I'm at negative 2/3, which means that's also what's happening here. So this is a little upside down parabola, and that's going to be the graph of my function. And then go ahead and check that with a graphing utility, and we can see that we did an awesome job. So try this one on your own, and then press play to check your work. Again, my numerator, I would look at, first of all, taking out a 2. So if I took out a 2, that gives me x squared plus 4x plus 4, which gives me x plus 2 quantity squared as a numerator. As a denominator, I've got a negative 1 and then an x plus 3 is essentially what I have. Negative 1 and then an x plus 3. To find the intercepts, first I would plug in 0. And if I plugged in 0, that would give me 0 plus 2, which is 2, squared, which is 4. That's 8 on the top. And then 0 plus 3, which is 3 times negative 1, so negative 3. So that's negative 8/3 for my y-intercept. It looks like I'm going by 3s here. So I'm really stinking close to this point. That's my y. For my x, remember, I'm just going to look at the numerator. I'm going to say what values of x would make the numerator 0, and that would just be negative 2. Oops, that's somewhere in here. Negative 2. So just at negative 2 is the only time that it would cross the x-axis. Now let's look at asymptotes. I've got x plus 3 on the bottom, so negative 3 is an asymptote here. X equals negative 3 is an asymptote. Looking at this original one, I've got the degree on top is 1 greater than the degree on the bottom. So if I looked at 2x squared over negative x, that would reduce to negative 2x. This is actually a slant asymptote. So negative 2x means it starts here, it goes up 2 over 1. Nope, sorry, it's negative, down 2 over 1, or up 2 to the left 1. So this slant asymptote is going to look like this. This will be fun. We've not done one of these before. And now what? Do I have any symmetry? I can pretty much pop that one out the window right now because my asymptotes pretty much show me there's not going to be symmetry. So now we just have to sort of figure out what's happening at each of these points. So let's try plugging in negative 6 because that's right here. Let's see what happens at negative 6. So f of negative 6, again, it's easier generally to use this one. So negative 6 plus 2 is negative 4. Squared is 16 times 2, that's 32 on the top. Negative 6 plus 3 is negative 3 times negative 1 is positive 3. So this is going to give me a positive value that's really close to 11. So at negative 6, I'm close to 11, which is up in here, right about there. I could plug in another point, but I'm pretty certain that obviously this is going to follow that asymptote, so it's going to kind of look like this on that part of my function. I know down here I've got something going on because I've got these 2 points. I'm guessing it's going to kind of look like this. Again, I could be more exact by plugging in more points. And then I want to see what happens if I plug in, say, 3. So let's find f of 3 and see what happens there. 3 plus 2 is 5, 5 squared, 25 times 2 is 50. 3 plus 3 is 6 times negative 1, that's negative 6. So 50 divided by negative 6, we're looking at maybe like close to negative 8, negative 9, somewhere in there. So if I plug in 3, I'm down, oh, yep, kind of wasted that one. So I know I did that. I know I did this part right at least. Let's plug in 9 and see what happens. F of 9. 9 plus 2 is 11. 11 squared is 121, so 242. Big number. 11 plus 3, 14 times negative 1, that's negative 14. I have no idea what that is, so I'm going to have to use my calculator. And it looks like that's a negative value as well, negative 17, which means nothing's happening over here. It's all happening between those 2 little diagonals. again, go ahead and graph that function with the graphing utility to check your work a little bit.